Hello and good evening to Madam Akila. Today our group will be present about differentiation. Before we move on, I would like to give a small introduction about differentiation. Differentiation also can be known as the derivative, which defined as the rate of the change of one quantity and respect of another. In terms of functions, the rate of change of the function is defined as dy over dx equals to fx over y. The concept of derivative has been used on small scales and large scales. The concept of derivative is used in many ways, such as change of temperature or rate of change of shapes, size of an object, depending on the condition, etc. Team roles and responsibilities. Slide PowerPoint, which done uh, by myself. Real life application and information gathering done by Divesh Warren, and calculation done by Tirumurugan, and lastly video editing done by Avinash. And that's all from me. Thank you.
Hello, my name is Diveshwaran son of Panogaran. My matrix number is 01DKA22F112. Today I want to talk about example application of differentiation in real life. The first one is business. One of the most common applications of derivatives of differentiations is when data is computed on a graph or a data table like an Excel sheet. Once there is an input, one can calculate the profit or loss by means of derivatives. Another one is swimming pool. Integration determines the amount of water used to fill a swimming pool. We first need to determine the shape of the swimming pool and find its size. Therefore, we find the amount of water that will fill it. If the swimming pool shape is not the regular geometric shape, it begins with a slight gradient.
It's business. For an instance, we started a small business in a town where people craves for one thing: cupcakes. It is the first day of your business. A person finally bought a cupcake. We shared about it. And now, the others have heard about it too. Within the next days, the number of cupcakes you sold grew uncontrollably, starting from 1, 2, 3, 4, until it reached a gazillion million cupcakes. And take note, each of these cupcakes cost $10, which means a gazillion million cupcakes sold, a gazillion million dollars earned. However, after a while, you notice that your revenue is decreasing, but you sold a lot of cupcakes, right? So you asked your staff for a report. You were impressed by the growth you see in the graph of your sales. Where did all your earnings go? Is someone stealing your money? The answer is no. Maybe you weren't considering other factors like your milk is being imported from a town far away and one transportation costs a lot. Therefore, making more cupcakes would cost you a lot as well. So, let's look at the sales report again.
As mentioned earlier, derivatives defined as dy over dx is the equation which gives the slope of the curve of the tangent line of a function. The slope gives you an idea on the marginal cost of producing an additional cupcake. The numbers on the x-axis show the units you produced and the y-axis shows the profits you gained.
Let us take for example the equation c of x is equal to 2500 minus 10x minus 0.01x squared plus 0.0002x cubed, where x is the number of cupcakes produced and c of x is the cost of producing x number of cupcakes. If you want to figure out the cost of producing 200th cupcake, for example, you cannot simply substitute 200 to the equation because that is the cost of producing 200 cupcakes and not the 200th cupcake. You want to compare the marginal cost of producing the 200th cupcake and the 300th cupcake in order to figure out how many cupcakes you should produce to gain more revenues. So with the equation given, you will have to derive the function and compute for the values of the derivative.
So in order to produce the 200th cupcake, it will cost approximately $10. However, remember that you're only selling the cupcake for only $10. So at this point, you didn't gain any profit. On the other hand, to produce a 300th cupcake will now cost around $38, which is $28 higher than the original price you sell your cupcakes. In this case, you didn't earn any profit. At the same time, you also spent your money on your bank. Now you know that as you increase the number of cupcakes you produce, the greater the marginal cost. With the gathered information, you will now have to evaluate the potential revenues and losses you may encounter if you decide on how many cupcakes you will produce. In that way, you may not only monitor the current state of your business but also decide on whether you will increase your production or not.
So, a very good morning to everybody. So, my name is Thirumurugan, son of R. Karunagaran. So, and my matrix number is 01DTA22F1122. So, today I would be explaining about the solution for questions G and H. So, if you look at question G, we have y is equivalent to 4x power cube minus 2x power of 2 minus 5x plus 1. So if we convert it to dy dx, differentiate it, we get that 12x squared is minus 4x minus 5. So when dy dx is equivalent to 0, then 12x squared minus 4x is minus 5 is equivalent to 0. Now we now have a quadratic formula, so we can use the quadratic equation, or we can use our calculator to get the value for x. So if we look at that, we actually got the first value for x is equivalent to 5/6 or 0.83, and the second value for x is -1/2 or -0.5. So the next step should be, when we found out the values of x, we just have to, in order to find the value of y, we just have to compare it, or we just need to put it in the first equation. So now we just put it back. So y is equivalent to 4 times 5/6 cubic minus 2 in bracket 5/6 power of 2 minus 5 times 5/6 plus 1. So the n value for y should be -121 over 54 or -2.24. So the stationary point for this particular equation is 5/6 and -121 over 54. So for the second value for the x is, we just do the same thing back again. So we just use 4 in bracket -1/2 power of 3 minus 2 in bracket -1/2 power of 2 minus 5 times -1/2 plus 1. So that n value for y is for y should be 7/2 or 3.550. So the second stationary point of our graph should be -1/2 and 7/2. So after finding the stationary point, we should just move on in order to find if our graph is in a maximum point or a minimum point. So in order to do that, we just have to differentiate it again. So it's the second degree differentiation. So if we do that, we get the value of 24x minus 4, and then we just put back the value of x that we got before inside the equation back again, and after that we actually got 24 times 5/6 minus 4. So the value we got is 16, which is higher than 0. So it is a minimum point. So in conclusion, we can say that the stationary point of 5/6 -121 over 54 is a minimum point. So the second degree differentiation for the second value of x should be 24 times -1/2 minus 4. So the second value is negative 16, which is lower than 0. So the graph is a maximum point. So the point is negative 1 over 2. 7 over 2 is a maximum point. So if we draw back all the points and connect it together, we actually should be able to get our graphs like this. Moving on to our second question, which is H, is y is equivalent to negative 4x cubic plus 2x squared plus 5x plus 1. So if we differentiate it in the first form, it should be negative 12x squared plus 4x plus 5. So when dy dx is equivalent to 0, the value should be negative 12x squared plus 4x plus 5 equals to 0. So the same as before, if we do it in a quadratic formula, we could get that the first value of x is negative 1 over 2 or negative 0.50, and the second value of x should be 5 over 6 or 0.83. So when x is equal to negative 1 over 2, we just have to substitute it in the first equation, which is y is equal to negative 4x cubic, 4x cubed plus 2x squared plus 5x plus 1. So if we substitute the value of x inside it, we actually get that the value of y is now negative 1 over 2 or negative 0.5. So the stationary point for this question is negative 1 over 2, and the y value should also be negative 1 over 2. So now when the value of x is equal to 5 over 6, so we just substitute the value of x inside our equation, and we get the value for y is now 229 over 54 or 4.24. So the stationary point is now 5 over 6 and 229 over 54. So if in order to find out whether our graph is a minimum point or a maximum point, so we have to do the second degree of differentiation. So if we do that, we actually get that negative 24x plus 4, and we just have to substitute the value of x that we got before inside it, and we actually get the first point is a maximum point, which is negative 16, and that is lower than 0, so it is a maximum point. So the coordinates of negative 1 over 2 and negative 1 over 2 is a maximum point, and the second one is the same thing, and if we substitute the value of x, which is 5 over 6 inside the equation before, we actually get the value of 16, which is higher than 0, and it is a minimum point. So now the coordinates of 5 over 6 and 229 over 54 is a minimum point. So if we draw the lines and connect it, we actually get the graphs, which should look like this.
Hello, my name is Avinash. My matrix number is 01DK22F1119. The summary for today's presentation is differentiation in mathematics is a process of finding the derivative of rate of charge of a function in contrast to the abstract nature of the theory behind it. The practical technique of differentiation can be carried out by purely algebraic manipulation using 3 basic derivatives, 4 rules of operation, and a knowledge of how to manipulate function. Thank you.